Hello, today we'll be going through another chapter for physics, which is the chapter on static electricity. So this chapter has basically no formulas. All you need to know is really just go and understand how the charges move and all that, which I'll be going through with you now. Hello, welcome to this new lecture series. Today I'll be going through this portion on static electricity. So static electricity has no formulas in it. The main thing that you have to know is just try and understand how the charges move and why the charges move. So let's go through this simple portion over here first. This one are basically your foundational stuff that you have to know. So an atom is neutral, and then you have electrons, which are negatively charged. So when your electrons are removed, you have more protons as compared to electrons, and so your atom or your substance will become positively charged. And then when you have an electron that is being added, it will become negatively charged because you have more negative charges as compared to positive charges. So next one over here, this one is extremely important when it comes to explaining your answer. So this one over here, you need to talk about like charges repel and then unlike charges attract. So whenever you talk about the movement, you need to refer back to this thing over here, which is that like charges repel and unlike charges attract. So for this chapter, another thing that you have to know is something called the SI unit for charge. The SI unit for charge will be covered in another chapter more in depth, but for now, just know that it is Coulomb, and then you have this big letter C over here. Okay, so next portion over here, so how are objects electrically charged? So there are multiple ways for objects to be electrically charged, but let's talk about insulators first. So for insulators, they don't conduct electricity, meaning to say they don't allow electrons to pass through it and move around it. So for your insulators, there's only one way for them to be charged, and that method is called friction, charging using friction. So an insulator is something that doesn't allow electricity to pass through it. So it doesn't allow electricity to pass through it. So for an insulator, there is only one way of charging it, which is charging using friction. So what happens is, let's say I got cloth, and then let's say I got a sphere over here, which is a plastic sphere. So whenever you're using this method, you cannot be using conductors. You can only use insulators. So let's say I have a plastic ball, and then I have like a cloth over here. So what happens is, if I were to rub them together, what happens is some electrons from here will move here. And when some electrons from the cloth move to the plastic ball, what happens is you will have a plastic ball which is negatively charged, and then you have a cloth which is positively charged. So that's the idea behind charging using friction. One more thing, make sure to remember that the movement of charges can only be the movement of negative charges. So what do I mean by that? You cannot say positive charges move, you can only say the negative charges or the electrons move. And that one is extremely important when it comes to your explanation. So let's go on to how you would explain something like this. So when a rod and a silk are rubbed together, electrons from the rod are transferred to the silk, and this causes the rod to have an excess of positive charges, and then thus it becomes positively charged, whereas the silk will have an excess of negative charges, and thus it will be negatively charged. So for the movement of the charges, you go based on the question. So if let's say the question says the silk is negatively charged afterwards, and then the cloth is positively charged. So what happens is when they are both neutral, the cloth will pass on electrons to the silk. Let's say if the question changes, let's say they say silk is positive and then your cloth is negative. So in this case, you will talk about the silk transferring electrons to the cloth. So go based off the question, your electron transfer direction will be based off what the question tells you is negatively charged. So next portion over here is charging using induction. So charging using induction means that you charge without contact. So you have, let's say, a rod over here and then you have a sphere over here. So you don't like touch them together. You place them in separate positions and then you'll be able to charge this sphere over here. So there's something called an earth wire. So the way for you to draw your earth wire is like this. And what does the earth wire do? The earth wire allows electrons to flow either into something or out of something. Okay, so we'll move on to this portion over here. So how exactly do you charge a conductor? So let's say I have a positively charged rod over here and then I have a neutral sphere over here. So let's say I move this rod closer to the sphere. What happens? So when this rod over here is moved towards the sphere, what happens is the negative charges in this sphere, right, it will move towards the left hand side and then leaving your positive charges on the right. Okay, so the free electrons in the sphere will be attracted by the positive charges in the rod and will move towards the left as unlike charges attract. So when you're trying to explain your answer, make sure to always include all these things like your unlike charges attract and so on. And then hence this causes the left side to have an excess of negative charges while the right side will have an excess of positive charges. So this will be what happens initially when you move the rod closer to the sphere. So let's move on. So next one over here. So what your earth wire does, as we said previously, is it allows electrons to either flow into the sphere or out of the sphere. So think about it this way. Your earth wire, let's say if you were to put an earth wire over here, the earth wire can only affect the ones that are being repelled. So the ones that are attracted will be unaffected by the earth wire, whereas the ones that are repelled, they will be neutralized by the earth wire. So in this case, since we have positive charges on the right which are not attracted by the rod, your electrons will flow into this sphere, neutralizing these positive charges over here. So this causes electrons to flow into the sphere as they are attracted by the positive charges on the right. And then this causes the right hand side to be neutral and then the left hand side will be negatively charged. So after you earth the thing, it will become something like this, where your left hand side is negative and then your right hand side is completely neutral. So this is how it works. So next one, if we were to remove the earth wire, what happens is, let's say if you were to remove this earth wire and then after that you remove your sphere, what happens is your negative charges, right, they will redistribute themselves because they are all negatively charged. And so because like charges repel, then they will repel each other, something like this. So this will be the end product after your step 4. So after step 4, it will look something like this. Okay, so let's say if I got the same setup again, let's say I got my positive rod over here and then I got a sphere. And then I have negative charges on the left and then I have the earth wire. So what happens if I remove the rod first instead of the earth wire? So if I were to do this first, what happens is your negative charges on the left, right, they are no longer attracted by the positive charges of the rod. So as I said previously, your earth wire cannot affect those that are attracted. But in this case, because the negative charges, they are no longer attracted by the rod, they will also be neutralized and then they will go into the earth wire. So the sequence matters over here, the sequence matters. So you need to make sure that you remove the earth wire first before this rod. Because if you don't remove the earth wire first and you remove the rod first, then what happens is you will have a sphere that is completely neutral, which is not what you want. Next one. So let's move on to this one over here. So I'll outline the steps to create a positively charged sphere from a neutral sphere. So it's similar to the ones that we did just now. So step 1, you need to place a negatively charged rod next to a neutral sphere. Bring it close to it, and so there will be positive charges on the right and negative charges on the left. So the way for you to explain this one is you cannot say that the positive charges are attracted by the rod. You need to say that the negative charges, they are repelled by the rod and so they move towards the right. So this is your first step. Second step, what you do is you attach an earth wire to the sphere. So once you attach an earth wire to the sphere, what happens is your negative charges on the right, they will go into your earth wire. So this one will disappear afterwards. And then after that, your step 3 will be to remove your earth wire first. So always make sure that you remove your earth wire first. And then step 4, you remove your rod. And then the positive charges will redistribute themselves as like charges repel. So this will be how you create a positively charged sphere. Okay, welcome to this second portion over here. So this portion over here will be on charging two different spheres. So it's exactly the same concept as the one covered previously. All you need to do is just treat that two spheres as one entire big sphere. So treat these two spheres as one big sphere. And so when you have a positively charged rod placed next to it, what happens is you will have negative charges being attracted to the left, and then you have positive charges staying on the right because they are repelled. And then after this, you don't need an earth wire in this case. All you need to do is just separate the two different spheres and then remove the metal rod, and your charges will redistribute themselves. And so you will have one positive sphere and then you will have another negative sphere. So something like this. So this one over here, create one positively charged sphere and another negatively charged sphere. So the idea is exactly the same as the one that we just covered. All you need to do is just place the negative rod next to two different spheres. And what happens is your negative charges, they are repelled, and so they'll stay on the right, and then your positive charges will be left behind on the left hand side. And then all you need to do is just separate the two different spheres like this, and you have one positive and one negative sphere. So you can use a positive rod as well. It will just be the opposite. So when you use a positive rod like this one, you will have negative charges moving to the left, and then positive charges staying on the right. And then what happens is you remove this positive rod, remove the sphere, and then you will have one positive and one negative charge. Next one. So this one over here is called charging with contact. So the idea for this one is just the movement of electrons. So you will have two neutral spheres over here, and then you will have a positively charged rod over here. So in your neutral sphere, there are also negative and positive charges as well, just that they are exactly the same, and that's why the net charge is neutral. So what happens when you place two neutral spheres next to a positively charged rod? So what happens is your electrons in these neutral spheres, they will be attracted to the positive charges. So they will be attracted to the positive charges in the positively charged rod as unlike charges attract. And so what happens is this will cause the originally neutral spheres, meaning the spheres that were originally neutral over here, to have an excess of positive charges. So the sphere will have an excess of positive charges. And then because some of the positive charges in the rod were neutralized, and so the rod will have lesser positive charges. So it will be something like this one. So you will end up having less positive charges over here, and then you will also have a positive charge and a positive charge over here as well. Okay, let's move on. So last portion over here, how are objects electrostatically discharged? So just now we covered one, which is the concept on earthing. So all you need to do is just place an earth wire, place it to the ground, and then you will allow the electrons to either flow in or flow out of the charged material. So there are two other methods that you have to know as well. One of it is heating with fire. So if you were to heat a charged material, what happens is your heat will ionize the air particles, and then the air particles will go and neutralize the charges in the material. Last one, so it is something called exposure to humid weather. So exposure to humid weather means that your water molecules, they will go and neutralize the excess charges. So it's something similar to the one on the air particles.